The next session is about, I think you heard from Taskin about Dent and SAI, how we are working and how we are doing the integration part. And Taras and Mano will be talking about how we'll be doing the testing of Dent and SAI. I think. So I would like to welcome both Taras and Mano. You want another microphone?
Yeah, can I have the second one? We can switch?
Yeah, it's one by one, right? Anyway. Just say in the microphone.
He's ready. The switch? Oh,
You can also control.
yeah, thank you.
Thank you.
Okay, hi everyone. So, yeah, Dent. We've been talking a lot about how it's great, how it's low footprint, how it's efficient, and now we were talking how it will be widely adopted by including the SAI. However, with the SAI integration, we faced a challenge. Unfortunately, let's be honest here, there is no set in stone contract between the NOS vendor and the SAI vendor on the behavioral model of the SAI. And we wanted to introduce the layer and introduce the ability and capabilities within the Dent project to set this contract. So the whole idea of Dent SAI testing is to provide the capability to verify and have this contract between NOS and SAI that this SAI implementation for this specific box is compatible with Dent. And the whole idea here is, we know that SAI is being widely adopted now. If you will take a look on what's available in the market, I believe there are several hundreds of platforms you can easily obtain and use it. So how you can utilize it? The idea is that by running the set of SAI test suits that will be developed for the Dent, you can run them on top of the SAI implementation you have on those specific platforms. And you can say, yeah, it will run even before you start migrating to Dent. And in order to achieve this, we could reinvent the wheel, and we didn't. So the OCP has the project called SAI Challenger. The whole idea of it is to test SAI. So the plan is to utilize that OCP project and basically define the set of suits that will verify that the SAI behaves, the platform behaves as the dentOS expects. So it consists in the two major parts. Number one is the test case itself and the testbed definition. The Challenger is, as I said, the OCP open source project. There is a client running which connects to the SAI server running on the box. And we also have the data plane, which is abstracted as well, and the capability to utilize hardware and software traffic generator to basically make sure that it's not just API-wise compatible, but also data plane-wise compatible. So how we're going to do it? The whole idea is the test cases are behavioral test cases. And I would have some more discussion, more information about those later in the slides. But the whole idea, they are. Sorry for that.
No, you're pardoned because you made the replay.
Okay. Yeah. So the whole idea that the test cases are functional wise and they are behavioral test cases. There are sets of functional calls to the SAI that configures it in a way that we expect. For example, this is how we create the route entry. We expect that when this route entry is created, the IP packet will be forwarded to the specified destination. And those test cases are not dentOS specific, and this is, I believe, the biggest advantage of those. We want to have this contract signed between NOS vendor and SAI vendor, and work with SAI community, work with OCP community to spread it across other NOS that utilizes SAI. And in order to, for SAI, it was simple to, it's simple because SAI is known, how to, API is open sourced. For the data plane perspective, I mean, we can always use API from Spirent, from Ixia, but I believe then it will limit us on the way how we can test it. So we've utilized so-called OTG to have it agnostic, and Mano will talk a bit more about OTG, excuse me.
Yeah. Thanks, Taras, and thanks everyone for being here. A quick introduction. I'm Mano from Keysight, and some of you might be wondering what's Keysight doing here, right? As part of the Dent community, Keysight helps maintaining the community test beds and also the community test framework, and we contribute all the test methodologies that we have from our 25 years of experience working with Ixia and Keysight, bringing into the community. And I will, since you guys already have an idea of what SAI Challenger is, I will introduce what Open Traffic Generator is and what it is doing in the SAI testing framework. We started with Open Traffic Generator kind of a couple of years back, and we started building the model first. This model-based approach let us make an API which is completely vendor neutral. So any traffic generator, be it an open source or a commercial traffic generator, if it complies to this model, any user can use the same SDK that we have developed in Python or any other language to write code to make a traffic generator work seamlessly. This is an open API, standard-based API framework. And what we have done is we have opened it to the community so that we can make use case-driven development here. This website, otg.dev, I would encourage everybody to take a look at it. It has tons of information on what we are doing with this open traffic generator and what's our motivation behind making such an API. We also have all this inside the GitHub repository, which are linked to that website. So I will definitely encourage you to try to take a look at this otg.dev website. So what is the advantage that this OTG brings you, and how is it important to Dent and especially with this SAI testing framework? So in the past, what we have seen is, and it's very common, like even if you go to the Sonic GitHub and Sonic testing repository, you will see a lot of PTF tests being developed, right? And down the line in the testing cycle, we see a lot of people starting to use commercial traffic generators, hardware traffic generators for different other use cases, right? For line rate traffic generation. But in each of these cycles, users are developing scripts or scripts with proprietary APIs. So each of these scripts in each of these cycles of the testing are being developed for specific to a particular proprietary API. What that means is we are spending cycles rewriting the same test over and over again, but we cannot reuse and rinse and repeat the same test cases. What Open Traffic Generator is enabling this ecosystem is right from the left-hand side where we are in a virtual test bed, in a software-defined test bed, we can use container-based traffic generators like Ixia or even some open implementation of Open Traffic Generator using PTF and move that script over to the later cycles of the testing where we can start using traffic generators like commercial traffic generators down the line. So far we have been, this is showing you how the data model kind of translates into SDKs and how the scripts end up in the tests. So we, again, as I said, we started with the model first approach here. And we implemented some of these SDKs, including Snappy in Python and Go Snappy in Go. Snappy is widely used in Sonic today as well to upstream all the test cases that we are contributing to Sonic. Now it's coming to Dent as well. So Dent has a huge test framework which is written in mostly Keysight proprietary APIs, but now we are also bringing in Open Traffic Generator with this SAI testing framework, SAI Challenger, to make it more open. And once user writes the test scripts and it talks Open Traffic OTG APIs to any of these implementations on the far right, including the Ixia container-based, which you see in the top, and IX Network and T-Rex and whatnot. Ixia-C is very important, and I think Taras's demo will also have Ixia-C in it. So with Ixia-C, we have brought a community-based, a community edition, which is free to use. So you're welcome to, again, go to the otg.dev. We have GitHub links in there on how to download and start using it. So that's kind of a free open source container-based traffic generator on which you can start building your tests and later migrate into higher speeds or higher speeds and feeds and traffic hardware-based traffic generators. So before I hand it over to Taras, so in general, OTG is the model-based hierarchical approach that we are taking here to build an API which can be which any traffic generator of today can comply to. And Snappy is the Python SDK that we are going to use for the demo today. So you'll see Ixia-C in real action and Snappy Python SDK in real action in the demo that that Taras is going to follow up today with. Thank you. Over to you, Taras.
Yeah, so as I said, we have the open source and well-defined SAI interface. We have the open source and well-defined traffic generator interface. So basically, it's the best starting point to write agnostic test cases. And this is a simple example how these agnostic test cases can be written. So as we can see here, it's the SAI call within the SAI Challenger framework. So we are talking to the SAI implementation and asking it to create a neighbor entry. And the second part of it's the definition of the flow. Within specific one, here we have the IP flow with 10 packets with 100 PPS. The idea here is this exact same code should be executed and work without any changes on Marvell, Broadcom, NVIDIA, Centec, and any other SAI implementation, and should work with Ixia-C, IX Network, T-Rex, and other implementations of the traffic generator. So this is the test setup. And as we can see on the right side of the, we have the test server where we have the SAI Challenger running and where we have the Shrifts client and the Ixia-C running. We have it connected to the DUT. At this moment, it's Debian 10 based with SAI's Shrift server running on it. We have 2 ports connected. And the whole idea here that with this we can test small rate PPS, like functional, maybe define that the MAC was changed, that the VLAN was switched, or something. But replacing the OTG with I don't know the model number, but I believe you can then point me to that one, but to the hardware traffic generator, you can have the same test being executed and testing that the line rate, would it be 1 gig, 10 gig, 40 gig, 100 gig, depends. I believe 800 gig is even possible.
Yeah, absolutely.
Yeah. And I would have a simple video demo. Can you please open the video demo for that? Where we will demonstrate how we have this SAI testing running. Mm-hmm. No, it shouldn't be audio, just video. Okay. So on the right top corner here, oh, oh, sorry, it's, please start it, yeah. On the right top corner here, we have the representation of the setup. We have the two XESC containers connected with the DUT. On the right left, excuse me, on the top left corner, we have the Shrift server running on top of the SAI implementation. Here on the bottom part of the device of the screen, we would have the test case execution. So what's happening? The SAI server has started and connected to the SAI. It listens to the on its standard SAI server port. We will now go. Oh, I can see it here. Yeah. Oh yeah, sorry. Yeah, so as we can see within the Open Traffic Generator, we are saying we are initializing XESC here. Once XESC is initialized, as Mano was saying, this is the container-based. You can deploy, you can grab it from the Docker Hub and run it. And we've started 2 containers. Then we would start the Shrift server, which is running, and then we would start the test cases. But before that, we would, the testbed topology definition will also be shown. Let's wait a second. So we started the Shrift client. I should run it faster, sorry. Yeah. So here we have the definition of the testbed. As you can see, it's basically generic ASIC. We have as the communication channel is Shrift. We do also support Redis, but it's not for this use case. As the data plane, we have the XESC running snappy, and we have 2 ports connected to the DUT. And we will start the tests now. So what would happen? The Challenger will. Yeah. Before that, we will take a look on the test itself. So as you can see, it's fairly similar test case. Just for the demo purposes of this, we have 2 connections. We are creating the VLAN. We are setting the VLAN traffic here. It's parameterized. There will be several VLANs created. Then we are creating the flow and checking that traffic was forwarded by the ASIC properly. So here, this is how we create a VLAN in SAI based on the SAI spec. Here, how we add ports to the VLAN. Here, how we configure the VLAN, PV, as you can see here. Then we are defining the data plane, and the flow, the MAC addresses, the VLAN IDs, the packet size. Then we do some IPs. Then we are sending traffic. And then we are verifying that we've received it as we expect, according to the test scenario. So as you can see, we are getting the statistics from the OTG and checking that we've received what we expect. The second one is the parameterized IP test cases. So it's for testing that the ASIC did route the traffic and did change its MAC. So first one was switching VLANs. Here we have routing. Same scenario. We have the router interfaces created. We have the neighbor entry created. Then we would configure the route entry, next hop, then ports. Shudar, can we speed it up this a bit? Can we speed this up, maybe? A bit more. Yeah, so same as for the layer 2 case, we are configuring the IP flow now and starting the flow and checking that we will receive packet according to the expectation of the test case. So now we will start the case. It will be discovered. As you can see on the right side, we see the SAI being initialized. Once SAI is initialized, we see that there are 2 ports being connected and went up. And I believe that the test cases is already passed because there are only 10 packets. And the idea here that by utilizing this, this tooling and this framework, we can have the exact steps we expect from SAI to do and exact data plane configuration we expect the ASIC to have. And we can check it from both sides. From the API perspective, that this set of instructions will be definitely resulting in this data plane behavior. And this will allow us then to make sure that by running that set of test suite, that we can run Dent on Dent specific box. And I believe I'm ready for questions.
Yeah.
Mano is also ready.
Is this working? Thank you. That was a really interesting demo. I had a couple of questions about OTG, and maybe I'm just trying to put it in context in my head. So does OTG also program the control plane? Can you use it to apply flows as you would through like OpenFlow or something like that?
So when you say control plane, yes. So let's say it's a traffic generator implementation. So let's say, for an example, in Sonic you're using PTF and containerized EOS to do the control plane there. So typically you're using 2 different APIs to talk to PTF to configure the data plane to the EOS to program the control plane. XCSE implementation has both the data plane and control plane in it. So basically, by using one API, you can configure your test to do the data plane as well as the control plane as well. So yeah, it can do both. Is that what your question was?
Yeah, it does. It was. I have a couple of. If no one else has questions, I have a couple of additional questions. Is it intended to be something like an iPerf or an MGen or something like that, where you can? I wasn't able to absorb like all the parameters and flags that you can add to it, but can you just tell it, okay, send 30 megabits of traffic for this long, send the packets of this size? Is that and then report out with a summary? Is it intended to be kind of like an iPerf 3 alternative?
That is exactly what it is. I would not compare ourselves with the iPerf. It's definitely bigger and better than that. So it does all the you can create flows, you can emulate your control plane, as well as on the other side you can sit and also get the metrics out of it. We are using JNMI to get the statistics and metrics out of the traffic generator and publish it to the user. So let's say you send Taras sent 10 packets, you can send millions of packets and then get the stats that how much you received on the receive side, what's the latency, what's your if there is any loss, that kind of implementations are there.
Okay, and can it generate multiple flows simultaneously, like multiple independent flows?
Yes. So in the diagram I showed you, there were different implementation of traffic generators, like from container-based up to no, there's one more back. So from the containers to hardware traffic generators. So they have different capabilities, obviously. So it's not that every implementation has the same capabilities. Like the container will have some limited capabilities, but if you go to the hardware traffic generators, we can create thousands of flows in there, and we can look at each flows and measure latencies on how each flows did.
Great, and if I could, just one last question. Within Keysight, how do you guys use this? Do you use it on servers? Do you apply it to hardware like the Aries or things like that? How would you guys use OTG within Ixia?
In all of the above. So yes, so on the servers, yes. As you see in the there's a container-based application that we have, implementation that we have, so that can run on servers. We can also run it on any of our hardware traffic generators, Novosys, Aresys. We also did POC level implementations for TRX and some of the other open source tools as well. So anybody, any traffic generator, anybody, like whether we proprietary, commercial, or open source, can come in and contribute to the community. So that's why we have opened it up through the GitHub. So if anybody can start contributing there. The models are there, so somebody can comply to that model and have the same script essentially to go and run it on their proprietary or open source traffic generator. Thank you. Any other questions?
What is the, do you have any performance numbers or something like what's the hardware requirement to be running OTG?
If I heard you right, your performance numbers and hardware requirements. Yes, so we have definitely measured that. So performance-wise, it's doing much better than our previous generation. So what we have done is we have leaned it out, the implementations. We have left out a lot of things and made sure that we are optimizing the implementation. So we have some numbers, I think, published in GitHub. I can get to that. But on the hardware specs, also we have published some of the hardware specs there. Again, since it's container-based, it's much more leaner, much more cost efficient in terms of the hardware spec that you would need to run such an implementation.
Great. Thanks.
Okay, thank you.